They screwed up on so many levels, it's beyond imagination. They really did. But the biggest screw up was not only did they not give us any resources to help us, but they also didn't tell us what would be on the test. They just told us topics, and one of the topics they said was scientific notation. So on the first day of the first test, now, by the way, how many opted out or expect to opt out this year? Just so I know. Virtually everybody. Okay. When I go through and I looked at the test, day one, there were 30 questions on day one, might have been 28, something like that. 7 of them were scientific notation. Fully 25% or more of the first day had to do with scientific notation. So do you get the idea this is an important topic?
Yes.
Yes, it is. All right. As always, fundamentals first. Let's make sure that we are understanding our sign number stuff. Now look, let's say that we do it, and you get every question right. It means you're doing perfect. Let's say we do it, and you get half of them wrong. God bless you. Bless you. And we get half of these questions wrong. Derek, turn. Keep those knees under the desk, all the way under. Good. If you get half of these questions wrong, that means you need to come to Extra Help, and you need to visit the website more frequently. Okay? So let's get going on that. Here we go. Number 1, -9 plus 2. What do we get? -7. Good. -8 minus -4. What do we get? Good, right? Circle out Gregor. 4 times -4.
16.
Good. 5 squared?
25.
-5 squared.
-25.
-5 in parentheses squared?
25.
25. -5 cubed? Not 15, -125. It's not 5 times 3, it's -5 times -5 times -5. Next, here I have -15 x to the 9th. Remember, multiply coefficients, add exponents. That's going to be a really big part of scientific notation too. That's why we've been hitting you on this and emphasizing it. If you remember, multiply coefficients, add exponents, and in the case of division, which we'll do in a moment, divide coefficients, subtract exponents, you are going to find most of the work with scientific notation very easy. Okay? 24 divided by 3? 8. X to the 5th, die. And this is going to be 8n to the 12th. Okay? Any questions? All right, good. We did that quickly, but today with the fire drill, we have to make some adjustments. In the words of the great Clint Eastwood, improvise, adapt, overcome. Whoa. Scientific notation. Dun, dun, dun. Yeah, this is a pretty big thing. I could say it's huge because the numbers are huge. How many people here are Italian? Raise your hand if you're Italian. Scientific notation is owed to you, and to you, and to you. You don't look Italian. I'm Swedish. You look Swedish. Blonde hair, blue eyes, the whole deal. I don't look Swedish. I look more Italian. So who'd have thunk it, right? So here's the deal. There was an Italian scientist by the name of Avogadro. That was his last name. Avogadro. And Avogadro figured out if I took a cubic meter, which is roughly 3 feet by 3 feet by 3 feet, a little bigger than that, but close enough. He figured out that there were, ready? I'm even going to write this on the board.
Why is it so big?
Oh, Jesus.
Oh my
Oh,
God.
no. You about to break the ink.
Hold it.
Break
hold
the
it.
ink.
Hold it. 3, 6, 9, 12, 15. All right, my commas are off by one place. It should be here, and so on. He figured out that that's how many molecules fit in a cubic meter of air at standard temperature and pressure.
How?
Now, don't worry what that means. That's chemistry. But that's a big number, right?
I don't even know.
I
what to call
had
it.
that much money.
Well, I wouldn't know what to call it either. But here's what happened. Avogadro figured that out. And then he would have a problem where he might have something like a warehouse. And in that warehouse, they'd say how many molecules of air is in the warehouse. Now, the warehouse is astronomically big. So he would take one really huge number and another really huge number. Let's say the other really huge number was this.
And multiply.
Yeah, and multiply.
Oh my God.
How in God's name are you going to fit that? Right? Don't you look at that and go, ha, No way. I hate doing it. I don't care. I'll fail. It is too much stuff. So Avogadro felt that way. And remember, I told you earlier this year that mathematicians are two things. They are brilliant and they are
Smart.
lazy. Mathematicians are brilliant and
I would say
lazy.
dumb.
So Avogadro started saying, Carmen, head in the game here, stop doodling. Avogadro started saying, hey, I can come up with a better way to do this. If you will, are you okay? All right, as long as you can talk, you're not choking. Avogadro came up with it. Basically, he learned how to build a better mousetrap. So his scientific notation made life really easy back in the day. And even calculators won't fit numbers that big. So this has good uses even with calculators. Now, how many people have seen scientific notation in either 7th grade math or science class? Okay, well, let me remind you of how to do this. Elena, head in the game. Ready? Check this out. Look. Scientific notation is always a number between 1 and 10 times 10 to some exponent, which is the number of places you move the decimal. So, for instance, 3.7 times 10 to the 5th is a number written in scientific notation. Now, how do you get from a regular number to scientific notation? It's pretty easy. The decimal would be here normally, right? We don't bother to write it, but isn't that where the decimal goes? Everybody with me on that? Now, check this out. 1, 2, 3, 4, 5, 6. Now, do you notice how this number has to be between 1 and 10? If I stop here, I've created the number 3.4. That's between 1 and 10. So the answer is 3.4 times 10 to the, now how many places did I move this? I moved it 6 places. So it's 3.4 times 10 to the 6th. And that is how you convert large numbers to scientific notation. Try the next one. Go ahead. Try it. Go ahead, you can screw it up, not a problem. Try it. Don't worry, try it, do the best you can, and then I will correct you, and you'll learn, by the time we hit the bottom of this page, you'll know how to do it. Okay, ready? Now this is a really big number. The decimal always begins here, at the end, at the end of the number. Now, 3, if I move the decimal to there, I've created 705. Does everybody see this? Look up.
Yeah.
Look up. Look, look, look. Does everybody see? If I move the decimal to here, I have 705. Is 705 between 1 and 10?
No.
No, so I got to keep going. Move one more place. That's 70.5. Is that between 1 and 10?
No.
No. I'll move one more place. That is 7.05 times 10 to the. Now, how many places did I move the decimal? 5. That's right. So that's the answer. 7.05 times 10 to the 5th. You try the next one.
I get it.
Another 15 seconds or so. Ten seconds. 5 seconds.
Did you just drink the whole thing?
No, I only have a tiny little bit left in it. Ready? Check it out. I like to move by 3s like the commas. So I go 3, then what do? 3 more. I'm still not between 1 and 10. I actually have to go 3 more, right? Because I have to create a number between what and what?
1 and 10.
1 and 10. If I stop here, that's 724.5. That's not between 1 and 10. If I stop here, what's the number?
72.
72.45. Is that between 1 and 10?
No.
But if I stop here, it's 7.245. Is that between 1 and 10?
Yes.
Yes. So it's 7.245 times 10 to the 9. Because I moved a total of 9 places. Okay? Elena, we looking good? Nice. All right. So let's go to the next one. 10,000. Try it.
Oh, no. I don't know if this-
What? Okay, ready? You're looking at my Tremix like you want some. I'm like, you just had your strawberry Pop-Tart there. Ready? I gotta learn to be like Ms. Mui over here. Ready? Oh, she gave me the eye look. She went like, that would be woman for you. You gonna die, sucker. Ready? Now, 3 places. I gotta go 1 more place. 1 times 10 to the 4th.
Bruh. Never mind.
Okay? Yeah.
What?
It does equal 10 times 10 to the 3rd, but when I say between 1 and 10, it means it has to be smaller than 10. Between them, not including 10.
Oh, you
Between
could have said that earlier.
Okay? Now, sometimes we need to work forward. Here's working forward. Ready? Watch. 3, 1, and it says 10 to the 3rd, so I have to move. It's supposed to be 3.1. See that? Everybody looking?
Yeah.
That, boys, right, Rach? It says 3.1. Here I am. I got to go 3 places. 1, 2, 3, and it's 3,100. If you doubt me, if you went backwards, wouldn't you get 3.1 times 10 to the 3rd? You with me on that? You always check yourself going backwards. Try the next one.
Oh, okay, I get it.
7.002 times 10 to the 8th.
This is magic.
Okay. Just wrote myself a note on the kind of question I want to include on an upcoming worksheet. Ready? I'm going to start with 7002. Now, how many places do I have to move from right after the 7? 8. That's 1, 2, 3, 4, 5, 6, 7, 8. Now, if I go backwards, 3, 6, 7, 8. That's right. 7.02 times 10 to the 8th equals 7002000000. Okay? Try the next one.
Do you just choose this period to eat? Or do you just eat all the way
I ate 2 periods before this, and I eat now, and I eat nuts and fruits and stuff, or nuts and trail mix. All right, ready? 7-2. Do I stop there?
No,
Do I stop there?
no,
Do I stop there?
no, too long.
I stop there, though, right?
No.
Do I stop there?
Yes.
All right, looking good. 720,000. Okay. Try the next one.
I don't know. I'm so confused.
It's not that negative.
Yeah, we'll get to negatives in a minute. Ready? It's 1, 1, 2, 3, 4, 5, 6, 7. Now, see the negative exponent here?
Yeah.
Watch, everybody look. Don't look away. Negative exponent means 0 point. Means it's a really tiny, tiny, tiny number. 0 point. 1, 2, 3, 5. You see how now I would move the decimal 3 points to the right to make a number between 1 and 10? So that's what a negative exponent means. Try the next one.
Wait, what?
See the negative exponent? That means start with 0 point, and then you're going to go 3 places until you get it between 1 and 10. All right? All right. We got robbed by the fire drill, but we will continue this tomorrow. Very much the same lesson. We'll stick forward and do what we got to do.
Do we do the homework?
Oh, yeah.
No.